Hi, thank you. I'm Jevonia Harris, and this is Joe, as he said, and we're here to talk about a project that we've done here at University of Delaware, where we took course materials and used knowledge graphs to create study guides and other learning objects. So we are a real small engineering team, a little IT team, in a department that is called Academic Technology Services, where it is kind of like the merging of teaching and learning and technology. And this department is pretty small because we do a lot of cutting edge technology and very custom solutions that we build. And then once we test it out, we kind of um, push it out into the campus at large. And I say this because one of the things that came about using new technology is we developed our own lecture capture system that will record the audio and whatever is projected on like their slides and things. And we built this maybe 15 years ago and put it through almost all of our classrooms. And this has been widely adopted by a lot of faculty members. So doing this allowed us to know the adoption rate of faculty members and also to be able to have a very good goodwill and connection with our faculty members. So when we do try new things, they're very willing to go ahead and try them out with us and give us feedback. So we have this really niche way of having new technology and the client themselves in our own little ecosphere. Next slide. So what we do, we created something called UD Study AiDE. And what we do is we have the faculty expertise being the main component. And then we use the generative power of AI to go ahead and transform that information. And we do this using knowledge graphs to go ahead and have all that information stored. So we had a proof of concept maybe a year and a half ago. And once we knew that it could be done, we went ahead and say, okay, once we know it can be done, what are the things that we need to consider before we build this for our university? So when we started planning it, one of the things that we wanted to do is make sure that it was ethical and make sure that we had all our I's dotted and our T's crossed. The goal of UD Study AiDE is to highlight our faculty's knowledge and their expertise while giving the learner the advocacy of being able to learn how they learn best. So we collaborated because we're at a university, we collaborated with all these experts in our educational sphere, librarians, philosophers, other computer scientists, and we were able to get the subject matter experts, which would be the faculty members, to weigh in on the things that AI is pulling from us and what is being generated. Also, we wanted to make sure that all of our data remains private. There's different levels of data. So for us, we went with AWS Bedrock and used the API endpoint of Claude for right now. And it could also connect with other LLMs so that all the service level agreements that Amazon Bedrock has with all these ChatGPTs, OpenAI, other LLMs also applies to our information. So this really nice, cute graph in a nutshell is what we do. We use transcripts, 20 years worth of transcripts from courses. So for example, it could be a psychology course that was taught by a professor many times a semester, 2 semesters in a year for many years. So we have repeatable data. And what we do, we take those transcripts and we run it through the AI and we gather the topics, the subtopics, and the definition of subtopics as the AI sees. When we do that, one of the things that we are really proud of is that we have the faculty members review those topics and they can go ahead and verify, they can reject it, and they can see the definitions that the AI has said. We have all those things, and we put all the verified topics into the knowledge graph and connect them to the pieces and chunks of transcripts where they came from. Once we have that, now we have all this structured human verifiable data, human verified data, and we use AI to go ahead for our clients, which would be the students on this side, to generate study materials and learning materials. So they can do customized learning objects, not just flashcards, but that's something that we do as kind of default. But now that we have all of this information that's verified from these faculty members, the sky's the limit. Whatever they can prompt, they can kind of have a structure as a learning object. And then, yep, turn it over to Joe.
So what we have now is, what you're seeing here is actually an early picture of a Psych 100 class, where faculty data is connected to topics, connected to material chunks that represent parts of that transcript. So what we have is human verified data that's going to produce for us really good learning objects. Our graph basically consists of links between the faculty member, the course, the material that was taught, and then that material broken down into smaller chunks that are basically connected via topic. The topics are connected in what we call sort of quote level, meaning the LLM was actually able to pull a quote and show us exactly where it came from. We then take that quote, trace it back to the transcript, and connect the topic that way. But we also use the vector indexing inside Neo4j to say, okay, does this material chunk, does this piece of transcript cover this topic? So if that threshold, the similarity score threshold, is high enough, we go ahead and connect it, and we also track that similarity score. We put in exactly what was found. Again, this gives us a way to go back and look at our data, because one of the things that we really like about this method is that we can figure out where topics came from, where learning objects come from, and then look at it again and say, okay, what is actually working well? What do our faculty members like? We can go back and say, you know, we thought similarity score of 0.75 was great, but they're rejecting a lot of that. They really want something higher. Once we had this was kind of our first graph. We were like, oh, okay. It started to trigger different things that we could do, because originally we were going to take our learning objects and store them in a different part of a database and come back to them. But what we've done is gone ahead and added our learning objects into the graph itself. So we now expanded the graph. So we have our course that connects to learning objects. Those learning objects connect to topics. Those learning objects connect to the material chunks. This gives us a lot more data to look at that goes beyond just our learning objects. As we thought about this, we realized, wow, we can start to take courses across disciplines and say, hey, faculty member, I want to see who teaches something about growth mindset. We did psychology, so I'll go with growth mindset. We could see where this topic is connected across the university, so we can bring faculty members together. We can now do more than just this learning object stuff. We can go beyond with these graphs. So how do we get there? We start by pulling our transcripts. We pull them out of, via API out of Kaltura, which is our video provider. It does the transcription and provides us with an API access to them. That allows us to sort what content the faculty wants to use and verify that the content is good. So we can do things like make sure that we're not pulling empty transcripts or transcripts that, you know, have caught only the first 5 seconds of a lecture. We package those transcripts together so that they can be used in different courses. If a faculty member teaches both a 100 level and a 200 level, they can go back in that 200 level and grab their 100 level as review into their later class. The other part that we do is allow our other ATS, Academic Technology Services members, to experiment with prompt development. What we've realized as we've done this, and I think as a lot of people have looked through this, is that prompt engineering is very important. So we have a database that breaks down our prompts into pieces. We have persona prompts, we have learning object prompts, we have output prompts, input prompts, and we can put them together and test and see what works in this prompt repository that we created. The idea is to be able to test those prompts to find the best output for the faculty member, because in psychology, one prompt may work best, but when you move over to something like biology, it doesn't quite work out as well. So we're able to fine tune those prompts, but still reuse pieces that we had before. So that prompt repository becomes very important. Lastly, we were able to combine our prompts together with functions that run on the server. Now, again, this is not part of the graph. This is just leading up to the graph. So this is actually stuff that's all stored in SQL. But it allows us, again, to test and find the right combination of prompts, transcripts, and whatnot to produce the best outcome in the graph for both the faculty member and then later on the student's learning objects. Once we have the best prompt, we run it through that prompt and get the results of, like Jevonia said, the topics, where those topics occurred, and what the AI sees as a definition of the topic. When we run it multiple times, because that LLM is going to return slightly different results with each iteration of a run. And so what we want to do is take what it produces in each of the 5, 6, 7 runs, combine those topics back together and pull out the ones that are the most likely to exist in these transcripts. So when we run it, they tend to come up with a whole bunch of topics that we can then reduce down to 25 to 30 main topics. Once we have those topics stored in our database, we then turn it over to the faculty. So what you're seeing here is a faculty interface, and this is going to walk the faculty from topic review all the way to publishing their learning objects to Canvas. So one of the things that we did that really encouraged faculty buy-in was that we gave them the ability to review everything that the LLM produces. And they can change that. So for instance, it gives us the topic of mindsets. If a faculty member decides that mindsets isn't really what we're talking about here, they can change that name. And that's what's going to be stored in the graph later on. Because our graph, we really only want to store that faculty approved information. All the other stuff we kind of keep in this SQL area. We also have the ability to change the definitions that the LLM produced. So if something doesn't seem to apply to our topic, we can delete it. If the wording is slightly off, we can change it. And again, that's what gets stored in the graph for the faculty member. It gives the faculty member confidence in what the outputs will finally be for their learning objects. It gives them confidence that these are correct things. These are things that they want in their course and not things that the LLM decided was in the course. So here's a look at some code. Hopefully you can see that well. Basically, this is code that walks through, it's in Python, and walks through our package content. It goes through each one, creates, if necessary, a subject for the transcript, it creates a course for the transcript, and it creates a faculty if necessary, and connects it all together. You can see it's basically using the standard Python packaging for Neo4j and some simple match, merge, and return statements. The interesting thing about this project is that we keep finding that things are simpler than we thought they would be. I think, Jevonia, you'll agree with that. That the graph especially just is such a natural place to store this stuff that we're just like, oh, okay, hey, this actually works. And it works pretty well the first time through. Here you can see us creating those vector indexes. So again, using the straight up LangChain package, we grab our documents here. It's using the Hugging Face and Struct embeddings to create those indexes. You can see it's creating the node, what our embeddings will be, and then down here, again, using that standard Python package, it connects everything together in that graph. And again, you can see taking those existing topics, finding them in the graph, finding the material, and then connecting the two together finally with that merge. Same thing with the AI version, except that here we're looking again at that minimum score. Does it, connects it? Not much exciting there. So what we finally end up with is what this course graph looks like. All of those, you can see the course in the middle there in pink, our topics in green, our smaller chunks of a material, our smaller parts of a transcript in orange, and our actual transcripts over there in blue. And they're all connected together in this graph so that we can easily find, again, a topic that's connected to a course, a topic that's connected to a faculty member, a topic that's connected to a subject, and eventually a topic that's connected to a learning object. So once the faculty member has approved those topics and the graphs created, we'll then run those topics through a prompt to create some kind of learning object. Currently, we do flashcards, but we're testing summaries and outlines. The idea being that we could eventually create practice quizzes and even knowledge maps that create sort of a, this is all the stuff you're going to learn in this course. The faculty member is then allowed to look at these objects that were created and approve them, reject them, just leave them sitting at the side for no reason. We can also give them the ability to add things to sets so that when they add a group of, they'll take a group of cards, add it to a set for a student to study from. So, hey, module 2, these cards all apply. I'm going to add that, create this set called module 2, add it as a link in my Canvas course. They click on it, boom, they're going to get all the module 2 cards. The other thing that we like is because we've done the connection between the graph and the topic and the chunk, we're able to see where this information came from so that the faculty member can confirm that, hey, I really did say this. In some cases, they might be surprised. But it gives them, again, that level of confidence in what they're doing. We also provide them, we take that similarity score and convert it into a high, medium, or low confidence for them. We don't want to make them look through, you know, floating point numbers. They just need something to know, hey, this card we're really confident in. So anything that's connected directly to a quote gets a high confidence. Medium and low come from similarity scores that are lower at a threshold we set. So that's how they can interact with these learning objects. And again, eventually they can see this is something like what This is their preview of what a card would look like. You can flip them, you can move through your card sets, all that kind of stuff. Here we have the student interface, what they will see. So there's a card set called the brain. It has 4 cards in it. They can move back and forth through that. They also have the ability to create their custom set, which is their study deck. And their study deck are the cards that they think they need to go over more and more. They also have the ability to download, which gives them the opportunity to, if they're a learner who likes to look at things, flip them, feel them physically, they can print them out, they can do what would be done with a regular note card, a regular flash card. Just another, this is what it looks like when they're in the study deck. So they have the ability to say, hey, I got this card. No, I don't got this card. I need to study it more, or I kind of get what's going on here. Again, it gives them the ability to see how they're progressing through their study session. Quickly, here is how we produce the learning objects from a topic. So we say, hey, this is the topic that we're going to look. So we replace, basically, we do a replacement in the prompt from the prompt database. All our topics are replaced by whatever's in the topic string. If we have input data, such as transcript data, we can put that there. Or if we have, well, transcript data itself, we can also drop that into the prompt. So again, using that stuff that was developed previously in the prompt repository and worked through with actual instructional designers of part of our group, people that really understand how to put together instructional materials for the web, we can develop all these prompts for them. And here, just real quickly, you can see how the prompt then gets sent to Claude through Bedrock. Again, we're using Bedrock for data privacy reasons, but it's, again, a basic Python setup and then returns the answer from the LLM. One of the things that's been really helpful is the ability of these LLMs to return things in JSON. So here, again, is the idea of what we would send to the LLM in a prompt to get back data that we can then store in the nodes. It's in the node itself. So the topic it's connected to, the front of the text, the back of the card, the node ID, all that kind of stuff. So where are we going from here? Again, we've used mainly transcripts at this point. We're now looking at, hey, what kind of other inputs can we take? Transcripts were great low-hanging fruit. We had a lot of them. They were text-based. They were easy to slice and dice and send to an LLM. So let's look at, the PowerPoint presentations a faculty member might have, the Canvas modules they might have, and see what we can produce from them. Quizzes, summaries, case studies, things that they could find useful in their courses. Eventually, we'd like to set it up so that faculty can prompt against their own data within reason. So we can give them some sample starting prompts that they can then tweak to get what they want. So that's what you kind of see here. What subject are we in? We're in psychology. What difficulty level do we want to produce of a learning object? What type? And then what kind of template? It produces something that is editable by them. So you can see the learning level prompt here that gets produced. They can edit that, the template or the learning object type. Again, the text is kind of pre-filled, but they can edit it. But it does things for them like put in these little special, replacement tags that they can use. And then here, again, they can generate the objects from those prompts and see what they get, tweaking it as they go to see if they get other stuff. So where are we going with the graph? So what we realized is if we can kind of track the study session, the way the student moves through the deck, we can tell them something about how they study. And we can help them find the best way to attack studying for a test or studying so that they can write an essay or a paper. So the idea here is that we'll create these study sessions, these blue nodes here. We'll track how long they've gone through that session with a start and end time. We'll track which learning objects they went to, one after the other, and in what order, to see how many times they had to revisit a topic, how many times they had to go through a whole deck, to see what worked for them to get to something they felt confident in. So if you had any questions for a couple minutes, we answer those. We looked at ontologies like EQF and ELM. We've actually talked with our, so we're part of a university. We have a university library system, and we've been talking with our, oh, I lost the word, library or taxonomist or something. There's a term in the library for people who go through and develop the taxonomy of a subject.
Yes.
And so we've been talking with them to get this idea of what would be in a standard psychology class, and then how do we link that standard psychology terminology to the terminology that the faculty member has come up, so that we give the student then the ability to go ahead and do what we call parallel research, which is to say, hey, this let me learn more about this topic of well-being. Click on it, and you can go to our library research, our library resources that connect to something like well-being or whatever that would be called in there, the library's standard taxonomy. So yeah, we've been trying to use the resources that are in the university to really push what we can do with this. Once we had this graph down, have we used it? We've looked at the data science tools. We've started to look at that now that we have kind of these ideas in place, and we would really like to use those, especially as we come up with things like the study session. We figured, or we feel like that would give us just really help us help the student, which again is what this is for. This is to help a student learn to study at a higher level when they got a ton of other things going on at the university.
No, the code isn't open source, but feel free to reach out. We are really big on collaboration, especially if other higher education institutions want to compare notes and learn together. And we just recommend that you use the resources available to you. There's a lot of more experts around you than you probably know.
Right.
And we've learned a lot from almost every area of the university to be able to do this project.
Cool.
Thank you all.
Yeah, thank you very much.